What's up, everybody? Today, what I want to talk about is I want to talk about operations with functions, and I want to talk about composition of functions. So, operation with functions is pretty easy. It's like adding, subtracting, multiplying, dividing functions, and then just kind of going through some stuff with that. And then actually, the more challenging stuff would be the composition of functions. So let's just kind of talk about it. When you see the notation of f plus g of x, that literally means, it 100% means take the function x and add it to the function g of x, right? Same thing with subtraction. That's easy enough. Multiplication, it's the same. You multiply the two functions together. It's very, very easy. It's just like we did with regular old stuff. So it's f of x times g of x. Now the division is exactly like it says, f of x over g of x. So how does this work? How would we do this? If you look at the first guy, um, actually, you can read this, the domain of the function, combined functions. Basically, it's the intersection. What do they have in common? Realistically, you don't have to worry about too much with the function stuff, the domains, except when you do division. When you do division, you got to watch out when g of x is equal to 0. But if you look at the first example here, x squared plus x is f of x. And then the g of x function is that linear guy right there. And they want us to do all the operations with it. So I'm going to do this with you real quick. And then you will probably have to do example 2 on your own. And I'll do example 3. We'll just kind of alternate a little bit. You'll pause the video and whatnot. So check it out. If we say we want to add these guys together, we're literally going x squared plus x plus 3x minus 1. So when you do that, what can you get? You get x squared plus 4x minus 1. And the domain here is all reals. How come I know that? Because the domain of all polynomials is all reals. Now, when you look at subtraction, you're going to say it's probably easier to go x squared plus x, right? But then it's minus 3x minus 1. So what happens there? X squared plus x minus 3x plus 1. And what does that get you? It gets you x squared minus 2x plus 1. And that's a polynomial, so its domain is all reals as well. Okay? When you look at multiplying, when you multiply these guys, that's the same thing as when if we had to FOIL. So realistically, if I'm going to multiply them, I'm actually going to go old school and go 3x minus 1, like that. And I'm going to go an x squared here plus x. This gets me 3x cubed. This gets me negative x squared. This gets me 3x squared, and that gives me negative 1x. So when I add it together, I get 3x cubed plus 2x squared minus x. And that's a polynomial, so my domain is all reals. When we talk about division, well, this is interesting. You just can set it up as x squared plus x over 3x minus 1. Now that's it. That's all it is. It's x squared plus x over 3x minus 1. Now if you could factor, you could, but then you got to look at the domain. Realistically, you set this denominator equal to 0, and wherever that's 0, it can't happen. So if you set 3x minus 1 equal to 0 and you solve, you'd see that the domain is everything except x can't be 1/3, if that makes sense. So what I'd like you to do is I'd like you to pause the video. I'd like you to do example number 2. Okay, so pause the video, do example number 2, and I'll see you back here in a couple minutes. Okay, so let's do number 3 together. If we add these guys together, you got 2x cubed plus x squared minus 4x. That's it. That's literally how it is, and its domain is all reals. How do I know it's all reals? Because it is a polynomial. If we subtract it, you got 2x cubed, and I'm going to go minus x squared minus 4x. And if I do that, I get 2x cubed minus x squared plus 4x. And since that's a polynomial, guess what? Its domain is all reals. When we multiply this one, we're going to go 2x cubed, and then we got x squared minus 4x. That's just distribution. That gets me 2x to the 5th. That gets me negative 8x to the 4th. And oh my gosh, it's a polynomial. Its domain is all reals. Now this one, when we divide, you got 2x cubed over x squared minus 4x. Well, you want to always factor because it kind of turns into a rational, right? So I pull that, I got an x times an x minus 4. This x goes away, that x goes away. I get 2x over x minus 4. Now this is good, except the domain is x cannot be 4. It's good to go everywhere but that. So that's how you do that. Why don't you pause the video? Why don't you do example number 5, and I'll see you back here in a minute. So the other thing you talk about is when you talk about evaluating functions. So basically, if you look at this, you got the function f and the function g. They want you to add it. They also want you to plug in 5. So it's a combination of both. So this one, we add them together. We get 4 minus x squared plus 2x plus 8. To make that a little more prettier, we're going to say negative x squared plus 2x plus 12. Now I just find f plus g of 5. So I plug 5 in. So I'm plugging 5 in. And when I do that, I believe I get negative, I get negative 25 plus 10 plus 12. And when I do all that, I believe 10 plus 12 is, what is that, 22? And I get negative 3. That's one way to do it. So the answer here is negative 3. If you look at B, it says f times g of negative 2. You could actually, if you wanted to, you could just find f of negative 2, and then you could find g of negative 2, and you can multiply them. You could have done that on the one on the left here too, if you wanted to. So if I find f of negative 2, if I do that, I plug that in, I get 4 minus negative 2 squared. And if I find g of negative 2, I get 2 times negative 2 plus 8. When I do 4 minus negative 2 squared, I get 0. And I'm going to multiply that by, if I do this guy, I think I get 4. So 0 times 4 is 0. So either one works, but it's pretty easy. Moving on, let's talk about the next thing, which is composition of, let's talk about composition of functions. This is interesting because when you do it, the method of composition, you start from the inside out. So you have f of g of x. You can rewrite this as f of g of x. It's a machine inside of a machine. So I like to say you start from the inside out. And when you talk about the domain of composition of a function, it's basically just, it's the domain, it's the input of the other guy's output. So you just got to play around a little bit. It's better to kind of do a couple of examples and see how it works. So if we look at this, they want us to find, they want us to compose f of g of x and then state its domain. So what does this mean if I'm finding f of g of x? This means literally anywhere I see the letter x in the function f, I'm going to replace it with the entire function g. So I'm pretty much going to find f of x squared minus 4. So I'm going to put in x squared minus 4 in place of x. So when I do that, I get x squared plus 3. Now, that's a polynomial, so its domain is all reals. Now, you don't get the same thing if I find this one's g of f of x. So this guy, I'm going to find g of x plus 7. So what's that look like? X plus 7 squared minus 4. So square the first term, that's an x squared. Square the last term, that's 49. Multiply the two together and double, that's plus 14x minus 4. So what do I get? I get x squared plus 14x plus 45. Completely different function, but it's also a polynomial, so its domain is all reals. Okay, its domain is all reals. I'm going to go ahead and do example 2 with you, and then you can kind of do example 3 on your own if you wanted to. So example number 2, f of g of x. Okay, so if you find f of g of x, f of g of x, that literally means anywhere I see the function x in f, I'm going to replace it with x over x plus 1. So there it is. That's a 1. Now we have to actually multiply that 3 by an x plus 1 over an x plus 1 so we can subtract it from this guy. Do you remember that from last unit? So then this gives me 3x plus 3 minus x all over x plus 1. Now when you do that, you get 2x plus 3 all over x plus 1. Now what's this guy's domain? This domain is good to go except x cannot be negative 1. Going the other way, this is g of f of x. If you go the other way, it's going to be 3 minus x all over 3 minus x plus 1. So you get 3 minus x upstairs, that's good to go, over 2, nope, it's going to be 4 minus x. So where is your domain? This is going to be x cannot be 4 because that will get you a 0. So that's how it works. Why don't you pause the video and go ahead and try the other examples. Okay, so hopefully that worked out. I want to talk about example number 6. I'm going to do that with you. This says basically find the composition and then evaluate it for 3. So I'm going to find f of g of x. Find f of g of x. That's the absolute value of negative 2 times x plus 1, and you close the absolute value. That's what that one is. Okay, that's pretty easy enough. So when we do that, we want to, if we polish this up, you get the absolute value of negative 2x minus 2, right? So if you do that, you find f of 3. So if you plug in 3, you take the absolute value of negative 2 times 3 minus 2. Negative 2 times 3 is negative 6. Minus 2 more is negative 8. What does that get you? That gets you absolute value of 8. If you go the other way, you want to find g of f of x, so g of f of x. And they want you to find that of negative 5. So really they want you, another way you could do it, they want you to find this g of f of negative 5. So another way you could do it, if you didn't like how I did it that way, is you could first find f of negative 5. And you get that answer. So if you plug in f of negative 5, that's negative 2 times negative 5, that's negative 10. The absolute value of that is 10. And then take that and plug that in for g. This is another way you could do it. So it's 10 plus 1, so that's 11. You could have done it that way as well. So either way, my first way I did was kind of confusing. I get it, but it happens. Now another complicated thing is what's called decomposition. Actually, you should pause the video, work on that example number 7, and I'll see you back here in a second. So for decomposing a function, that's kind of like, all right, check it out. This is saying, I gave you this function, h of x equals 1 minus 2x quantity cubed, and I need you to come up with two functions, f of g of x, that works. So when you think about it, you got f of g of x that gets you that guy right there. So really work from the inside out. This 1 minus 2x, this is the inside. This is probably my g function. And then the stuff outside, that might be my f function. So my f of x function is going to be x cubed. and my g of x function is going to be the 1 minus 2x. Make sense? Probably not. Let's do another one. I'll do another one with you. If you look at this guy, h of g of x, they want us to find f of g of x. So they want you to find f and g. So this guy right here is probably my g of x. So that's my x squared plus 1. And my f of x is just going to be cube root of big ol' X. All right? A little tricky, but that's okay. Look at the next one. If you look at the next one, we'll go with blue here. They want you to do the same thing. They want you to find the f of g of x. So I guess it's going to stay black. I want to go and make it. So I guess I have to look at what the heck is, if I had to think globally, this guy right here is probably my g of x. Because I'm working from the inside out. And my f of x is going to be 4 over x minus 1. Okay, now this one, same thing. Let's work from the inside out. I'm betting you this little ditty right there, that's my g of x. So g of x is that linear x plus 5. So f of x is what's left over. What's left over? Negative 1/2 times the absolute value of big ol' X plus 3. So I know this video went a little long. That's okay. You need, it's a lot of content, but I think you'll get the hang of it after you take some time and you practice and do a few problems on your own. And I wish you best of luck, and may the force be with you.